Hello everyone, welcome to our YouTube channel Learn Together. We are back with a new video of chapter 1 Chemical Reactions and Equation. And before that, I would like you all to subscribe, like, and share our channel. Now, welcome to the topic Types of Chemical Reaction. In this particular topic, we will be studying the types of chemical reaction, that is combination reaction, decomposition reaction, single displacement reaction, double displacement reaction, which is also known as exchange of radicals. So let's move to our topic. First is combination reaction, which is also known as addition reaction. And in this particular reaction, this is a type of reaction when two or more substances, this is very important key terms for your board exams, that two or more substances combine to form a single product. This is known as addition reaction. Suppose you went out to buy anything and you are going to add all the numbers together, you are going to get single number. It means addition means too many reactants and a single product. This is known as addition reaction. Here are some key points which you have to understand, that there is only one product form. So if the question asks identify the type of reaction, and you see that there is only single product, then it is for sure addition reaction or combination reaction. Okay, the reactants is not only that they should be compound, or this is necessary that they are going to be like they are going to be uh, element. They are always uh, reactants which are present in the form of element or compound. These reactions are sometimes exothermic and sometimes endothermic, so you cannot classify them that they are always something exo only or endo only. It depends on the types of reaction. Let's move toward the example of it. You see on the screen that there is first element that is written in magnesium, and there is a plus sign. When magnesium reacts with oxygen, it is shown like this. Whenever you have identified these types of white dazzling flame, it is always magnesium oxide, and the powder which is formed is known as white amorphous powder magnesium oxide. So this is how magnesium reacts with oxygen, producing light. If you see, there is heat and light both produced over here, but you see the residue is also there, and residue is a single residue, no other residues are there. So this is also a type of combination reaction or addition reaction. I hope you have understood this. Now we will be moving towards the next topic, that is decomposition reaction. This is also a very interesting topic, because this is also known as a reverse of combination reaction, because in decomposition reaction a single compound breaks down into two or more simpler substances. It means the combination reaction is having too many or multiple reactants in the single product, whereas decomposition reaction is having only single compound break down into two or more simpler substances. As you can see in this example, AB is there, which is further dissociated into A and B. Okay, so now we will move towards some key points that you have to understand. Only one reactant is there, so if there is a question in which you have to identify whether it is a decomposition reaction, if you see single reactant, it means it is decomposition reaction. Two or more products, this is known as decomposition reaction, and energy is required in the form of heat, light, and electricity. Okay, this is very important thing, because the Decomposition reaction is further divided into three parts. Three subparts are there, which we will be discussing in next part. Now, types of decomposition reaction we will be studying. There are three types of chemical reaction: thermal decomposition reaction, photolytic decomposition reaction, or known as photochemical or electrochemical reaction, which is also known as electrolysis. As you all know that the meaning of thermal is related to heat only. So when we are going to supply heat to a substance and it will dissociate, it is known as thermal decomposition. When we see that there is any light, photo means light, so whenever there is a light present in any of the reaction and the substance decomposes, this is known as photolytic decomposition reaction or photochemical reaction. Whenever there is a reaction which occurs in the presence of electricity, this is known as electrochemical reaction. Okay, so these are the types of decomposition reaction. We will be discussing the examples of this thermal decomposition reaction. When calcium carbonate, which is also known as limestone, is heated in the presence of heat, it is converting into quicklime, which is a solid, and carbon dioxide, which is a gas. Okay, so you see that there is one single reactant and two products, one and two products are there. So this is known as thermal decomposition reaction. These reactions can also be identified due to the presence of this triangle on the arrow. Okay, now move towards. Now we will be moving towards our next type of decomposition, that is photochemical reaction. You see that this is silver chloride, which is the having the formula AgCl, and when it is heated in the presence of sunlight, or no heat is required, only the sunlight is enough to decompose AgCl into silver powder, which is written as Ag, and chlorine gas. Okay, so the reaction is AgCl gives out Ag and Cl2. This is photochemical reaction. And then we will be moving towards our next decomposition reaction, which is known as electrolysis. Electrolysis means presence of electricity when decomposes two or more substances. So this is known as electrolysis. Here you can see water is there, electricity is there, and it is decomposing into hydrogen and oxygen. And in this particular diagram you see that on the negative terminal we are having hydrogen, and on the positive terminal we will be getting oxygen gas. Okay, so this is it for the decomposition reaction. Now we will be moving towards the next type of chemical reaction. This is single displacement reaction. As you can see, there is a word displacement. The meaning of displacement means one element is displaced by the other element. Then this is said to be a displacement reaction. When one element displaces another element from a compound depending on the position in reactivity series. Now one question arises, what is reactivity series? Okay, so we will be discussing what is reactivity series and how the positions are changing due to the presence of the uh, like top the series or bottom the series. Okay, so the reactivity series is written in front of you, that the very first element is potassium, then magnesium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver, platinum, and gold. So whenever you are taking any element, like suppose you have taken zinc, and you dipped it in magnesium sulfate. So the question is this: whether zinc is able to displace magnesium? The answer is no, it will not displace because zinc is lower than magnesium in the reactivity series. But if you have taken magnesium sulfate reacting with sodium, then magnesium will be displaced because sodium is upper in the reactivity series. So this is how the reactivity series uh, plays a very important role in displacement reaction. Now the very important question, that how to learn this series. Okay, so here is one mnemonic: Karina ने कार मांगी, अल्टो जेन फरारी, फिर भी है क्यों मिली सिल्वर प्लेटेड Ori, right? So now how to understand this? Karina means K. K means potassium. Ne, sodium. Sodium, this. Okay. Now if we move towards the next car, car means Ca. Calcium, Ca. Okay. Mangi, Mg. Mangi, Mg. That is magnesium. Okay. Alto, Al, aluminium, right? Zinc, Zen, zinc. Okay. Ferrari, Fe, iron, right? Now फिर भी, Pb, that is lead. Okay. He stands for hydrogen, that is H only. Okay. Q, copper, Cu, right? Milli, M stands for mercury, though I know that the symbol of mercury is Hg, but I have to set the mnemonic, so it is milli. Okay. Silver remains silver, that is Ag. Plated, Pt, that is platinum, and Audi, this is Au, gold. So in this way you can understand the concept of how to learn this series. So I am removing all these colors so that you can take a screenshot of it and start learning this mnemonic, so that it will be easier for you to complete the displacement reactions in the exams, upcoming exams, right? Okay, now moving towards our next slide, that is the important and very most asked reaction. Okay, so in this reaction you can see that there is a test tube in which you are having copper sulfate and one iron nail is dipped in it. Okay, so in this case, when copper and iron both are there, so you see in the previous slide, you must have seen in the previous slide that iron is placed above in the reactivity series in terms of copper, right? So iron will displace copper and copper will be deposited here in the form of brown powder, brown color powder, and the solution becomes brown and the substance becomes ferrous sulfate. Okay, so this is the reaction. Sometimes they ask you a blue color solution, a brown color solution, and all that cases are there, and the resultant is this reaction only. This is single displacement reaction because only one element is replacing the other one. Okay, now moving towards our last topic, types of reaction is double displacement reaction. As you have learned about single displacement, only one element is displacing the other element. Here both the ions are replaced. Both the ions are replaced. What is the meaning of this term? In this particular type of reaction, the ions of the two compounds you have taken exchange their position and they form two new compounds. Okay, As you can see in the example that AB is there. So AB will displace B and add D to it. So it will be becoming AD, and whatever is left will be C along with B. Okay, so here some points you have to understand, key points, that there should be two ionic compounds. It is not possible for an element to displace the other compound, because that will become single displacement. If you need double displacement, you need two ionic compounds. Exchange of ion should be there. Okay, and usually this reaction occurs when the solutions are prepared in water only. Often the results is precipitate, but sometimes there is a gas or water also. So now we can move towards our example, and the example is, okay, so on the screen you can see lead nitrate is there, which is a colorless solution. Potassium iodide is also a colorless solution, but when we are going to mix it together, one yellow color PPT is there and other is the solution left. Okay, so this is very important question that CBSE used to ask, in which they used to mention yellow color PPT. So that yellow color PPT is of lead iodide. Okay, in this reaction you can see lead nitrate is there, Ki is there, and lead reacts with iodine and potassium combines with nitrate. So the yellow PPT which you can see over here is of lead iodide only. The downward arrows denotes PPT. Okay, and potassium nitrate is left in the form of solution only. Okay, so this is it for today, and thanks for watching, and do not forget to like, subscribe and share my channel. Comments are open. If you have any query related to any of the topic, you can ask your questions. Thank you.